Hi, I'm Tim Burns. I'm a data architect. And I'm going to go over the value gap model and how we can use open source tools to address value gaps using lean principles. So, the lean startup principles are based on a book by Eric Ries written in 2011. And the idea that he had was that we validate our products with end users using an MVP, and we learn from user feedback. And so we deliver the value to the user, and we base development on what they tell us. So we want to build on any successes that we deliver. And then we want to abandon any aspects of the product that don't meet our user needs. So this is known as the MVP. And for a data product, we want to create an MVP that answers the business questions of the users as an analytical interaction. So I define the value gap as an unanswered business question. So we have to ask ourselves, what data do we need to answer the question? How fast do we need to get the answer to the question? Is this real time? Is this something that takes a day? Is this happen in a week, in a month? What is the SLA? How simply can we answer the question? Simplicity is key because that defines how much time it takes us to build something. Also can define how much time it takes us to get feedback, and lack of simplicity can make pivoting much harder. So, because the final thing is we want to be able to pivot quickly if the question changes or if the question wasn't correct to begin with. So I'm introducing 5 building blocks for a lean data architecture that I'm going to use in a matrix later on. So first of all, value. So the value gap model is essentially a value gap is essentially a use case that an MVP will seek to fill for building a data product. It's essentially an unanswered business question. Delivery, the idea of delivery here is that we put the data in the hands of the users as fast as possible and as simply as possible. So we need a platform to deliver it on. We need a BI tool. Security. Data that's valuable has to be secured. So we want to build that data using a secure infrastructure. I choose AWS. I know it well. S3, IAM, and KMS are my 3 favorite security triangles in AWS. Repeatability. We want to use Terraform. Terraform is a platform neutral system for automating infrastructure deployment. So it lets us build things quickly, and it lets us pivot quickly. Simplicity. We want to avoid waste by limiting custom code, and we want to utilize open source tools because we're not writing our own code. We don't have to be wedded to something that we have to throw away. It's open source. We can switch, we can pivot. So, first of all, when we look at the value gap, we're picking a use case in our architecture. So in this diagram here, I have grayed out sort of the standard inputs, the S3 buckets, the pipeline. And I really want to focus, rather than on the building, on the customer first, because we start with the data value gap and we use the MVP to answer those customer use case questions. So once we have defined the value gaps, we can create a matrix for each open question, and we can lay out a strategy for filling the gaps to align the work. Because ultimately we want to plan our work so that we can address the gaps in value order, and we can break down each aspect by the gap, and we can look for ways to speed delivery, because that's the key to our success. And we deliver on value grabs incrementally, and we want to minimize the throwaway code at every step by using open source tools. But we don't want to forget anything, and that's, I think, why I have delivery, security, repeatability, and simplicity as necessary fields that need to be filled in for each iteration, or could be concurrent iterations of the value gaps in a project. So first of all, philosophy into action. So there are technical needs for a project, and this is my background, my choices. There are equivalent technologies that do the same thing. Delivery. Snowflake is my choice. I think there's a multitude of BI tools. Tableau is my choice on the BI end. I like Snowflake because it doesn't tie you to a cloud provider. It offers all the benefits of a NoSQL system, a big data system, but it also offers all the governance and tools, SQL tools, that a traditional database would have. So it's really, in many ways, the best of both worlds. Security. I would have to say AWS is my choice for security. AWS is well proven. It provides a tremendous scalability and interoperability with S3. It has a rich network of options that you can use to protect the data. Snowflake is a native AWS tenant, so you don't even need to egress on the internet. Your data can be safe and secure well behind in the AWS backbone, behind VPC endpoints. It provides all the support we need to do encryption of the data, so we can actually keep all of our data encrypted both at rest, and we can ensure that only authorized principals can decrypt the data. So we can really keep it out of the hands of individuals, and we can use Snowflake then to provide the governance around who can see the data and who can modify the data. Repeatability. So I choose both AWS, Snowflake, and Terraform as my repeatability. So Terraform allows me to configure both AWS and Snowflake. For simplicity, there's 2 open source tools, actually 3. Airbyte is one. Airbyte is a tool that lets us gather data, raw data from data sources and load them. And there's dbt, which is a transformation tool. And then there's Airflow, which Airflow is an orchestration tool. So those 3 together, to me, make an essential part of a data infrastructure. And then they're run on Kubernetes. And why do I like Kubernetes as the runtime environment? Because Kubernetes is well supported. It's available on all cloud platforms. Again, you're not tied into a single platform, but it's well supported on AWS. So I think that's like a prudent developer builds on core security tools in their cloud platform, but for application tools, rely on application tools that can be ported, because you never know when you need to pivot from one cloud platform to another. Also, Terraform. Just a bit on the Terraform is an infrastructure automation tool with many providers to build the data architecture. So we can provision S3 buckets, IAM roles, KMS keys, Kubernetes clusters, do events and notifications, a lot with Terraform. And actually, we can also do Snowflake. So Snowflake, we can provision our roles, we can establish our governance, we can integrate Snowflake securely with AWS, and it's all independent of the cloud platform. So we can use Kubernetes on other cloud providers as well. Here in this project, I provide you a practical structure to use as a template. So, and the reason for this is as I want you to have a project that you can exist into your existing code. So use open source as a template so you can build in AWS infrastructure on your own account. It's driven by configurations. You can provision a Snowflake instance on your existing account. You can create the Kubernetes pods. You can run Airflow, dbt, and Airbyte to all run that within AWS. So, and I guess it gets to my next thing. My follow-on will be a value gap example. So what I really want to do is I want to show how we can build these things using real tools. So I picked an interesting question is, what are the top touring acts in alternative music? So I think it's a question. You could potentially even monetize this. I'm not doing it to monetize it, but I'm doing it because I like music. So what data do I need? So I would need to get a radio playlist data with the release date. So I could get a feeling for what's popular on alternative radio, what some of the hot new artists are. I can also integrate that data with ticketing data using SeatGeek for upcoming shows. And finally, what are my data sources? So basically, Open API playlists, SeatGeek or Ticketmaster, and then how often do I need it? I think I probably want daily reports. So I'll be going into that in my next video. But thank you for watching, and I appreciate it.